Students, welcome to lecture number 2 of this course on AI/ML in materials engineering. So, first we will see some recap of whatever we learned in the last lecture, that is lecture number 1. I introduced the course, or I made a small 10-minute presentation on the introduction to the course. That is basically for very simple thing, there is no need of recap of that. But then I told you why we need to use AI/ML in materials engineering. The requirement data and informatics is very important in design and discovery of materials. That is exactly I told you the last lecture. But again let us talk something small time on what is AI. AI is the ability of machines and computers to mimic human decision making as well as problem solving capability. And this ability, as you know, is very limited at this moment, but we are happy whatever abilities it has, and that is why we can do all kinds of fancy things using AI. And machine learning and deep learning are part of the AI, and AI is basically meant to use machines which can understand and achieve some specific goals. Therefore, machine learning uses structured data and deep learning uses unstructured data, which we will discuss a lot in the different parts of this course. So, now AI is only whatever AI we use today is only narrow AI, that is it can only do specific task, but it is not cannot do general task. That means general AI is still a dream to achieve, and it is a concept, it is still not close to whatever we can even think of. And AI routinely does speech recognitions, as you know. I told you about customer service, AI can answer customer service questions or even provide recommendations. AI uses computer vision to provide a lot. In a mobile phone you have a Google Lens, and that actually uses a computer vision. You take a photograph and then you can detect what is the type of flower, what is the type of fruits, or what is the type of what kind of faces. If Google has all the databases, it can easily detect it. So, that is nothing but use of computer vision. Universities use recommendation engines, many of them, they are actually all based on AI. And today's world, everybody knows about stock trading. Stock trading is also automated using thanks to AI. But why, why it is important for material science? That is what is the basic purpose of this course. So, I showed you this chart. This is a very important chart taken from Michael Ashby's book, which I will refer in next couple of slides. It basically tells you use of human materials in human civilization, starting from 10,000 BC to till 2020, and the time is counting on, right. So, as you can see, the importance of the materials vary as a function of time, whether it is a metal or it is a composite or ceramics and glasses. Polymers came much later, that is why it has not been discussed here, but these 4 sets of materials, or there are 3 sets of materials are very important in this world. Polymer is there, you can clearly see here polymer elastomers are very important, like bakelite, nylon, polyethylene, PMA, acrylics. Still today high temperature polymers are getting used in various applications. So, polymers are becoming more important in today's world as far as the relative importance is concerned. Let us talk about how the materials are selected for a particular application, and I am very happy to select this example because this is a day to day instrument which you use, a vacuum cleaner. And thanks to Professor Michael Ashby, which has described this application very nicely in this book called Materials Selection in Mechanical Design. It was published way back 1992, almost like 30 years ago, more than 30 years ago, but still it is very relevant. As you see here, vacuum cleaners are widely used to clean various kinds of things, especially carpets or walls, or sometimes computers or devices. But you see, these are the pictures 1905, more than 120 years, almost 120 years ago, 1950, 1960, 85 and 1997. I have not used the modern one which is available, right, which is even more fancy. So, first one was hand powered bellow cleaner, Okay, it was just like a binocular, largely made up of wood and leather. In those days, metals and polymers were not widely used. Metals could have been used, but they didn't use. It was wood basically which was naturally available. So, you can see till about last century we are using wood, naturally available material, for various kinds of instruments. And then in case of 1950s, vacuum cleaner became very sophisticated. We have used quite a lot of polymeric material, you can see here these tubes and these things, and also metallic. And then came in 1985, which was very lightweight, because this metallic part which is used here was heavy. In 1985, you are using lightweight vacuum cleaners made up of mostly polymers, little bit of metal like aluminiums, and last one is a centrifugal dust extraction cleaner of 1997. Today's vacuum cleaners are much sleek, much sophisticated. Some of them actually are computer controlled. You may have heard of room cleaners which are AI driven. So, they are the modern avatars of this. If I put together all the data, which is again taken from this book of Michael Ashby, in 1900s woods, canvas or leather was used. Power was very small, only 50 watts, because it is hand bellow driven. Weight was massive, 10 kilograms, and cost was something about $250. But in 1950 cylinders were used, but these are all not electrical powered, and they made of mild steels, which we can get up to about 300 watts of power. Weights have been almost halved, and cost has also reduced. 1985 again it was lightweight, that is why molded plastics and polypropylene was used. Power increased, power means sucking power actually. So, that is about 800 watts, and weight was further reduced. But then 1995 they are actually made of Dysons. I can see the polyethylene, polycarbonate, they are used. Power was again increased. So, 50 watts become 1200 watts in about 90 years. That is what it is. The weights reduced substantially, and this cost are basically obviously taken cost in 1998. Cost might have changed now. So, do not. So, the choice of material depends on time and design of the product, how you want. Another important aspect you could have seen is aesthetic of the products is also very important when you design something. So, therefore, these design parameters are basically was used manually to get this kind of products. So, now this one I showed you, right, the case study in the last class. A device is to open a corked bottle. If you want to take out a liquid from the corked bottle, you have to open the cork. And what did I show you? Okay, do not use this. These are accidents. Either you can break it, obviously any bottle can be broken by using some kind of by hitting it, or you can actually have an explosion on the top side, that also possible, or you can put some acid, it will also corrode the cork, but I doubt many acids do not corrode the cork. So, best way is to remove this cork by putting a screw inside it or a blade inside it. That is what is shown here, you can see here. So, selection of the device, the selection of the material for the device changes if you want to use a screw or something. You see that is what. So, this screw remains always metallic, you can't change it because it has to be hard, but these other things, whether you are using a spring assisted pull or a gear lever or a direct pull or even other kinds of things, that will dictate what kind of material you need to choose. So, design of this kind of devices requires selection of materials, what kind of material you use, that is what I am talking about it. So, these are the 4 things I showed you. Please go through this literature, this book is available, you can read it through, very interesting one, and design is very important. This one also I showed you, again taken from Michael Ashby's book. This is basically heat sink, and I showed you why we have to use metals or polymers, mostly metals for heat sink material, so that it can withstand about 1200 degree, sorry 200 degrees Celsius temperature. Well, I will talk about another new example now. You have seen probably high tension cables, right, because that is what is used to hang high power or so high current capacity high voltage cables, as you know, you must have seen in various villages or even near the cities. So, have you ever think about it, what kind of materials will be used for overhead transmission lines Obviously, you have a limited choice because you have to have a material which can conduct electricity. That means it should have very low resistivity or rather very high conductivity. So, but you always like to increase this span between the two high tension to these structures, and they are very expensive to make. The steel structures to be fixed on the ground, so they are very expensive to make. Also, they are going to occupy some space on the ground. So, therefore, idea is to create as long span as possible. So, constraint is the length specified, but if you have a long span, the weight of the wire will be sufficiently high to allow it to sag or allow it to bend. On its weight it will fall, and it might be very dangerous, because if it sag quite low, some person may get affected by this. So, that is what it is, and obviously the material should be strong. That means it should have a strength about more than 80 MPS, megapascals. So, that limits your choices. So, therefore, you have to have a minimum electric resistivity, you have to have a span well defined, and you have to have a material whose strength is more than 80 MPa. These conditions are imposed. What choices you have? So, if you put it together, resistivity, this is the resistivity or conductivity plots, you can see here thermal conductivity resistivity. So, resistivity should be as low as possible, right. So, resistivity should be something about less than this value, right, am I correct? And your choices are very limited, there must be metals only, because strength is also very high. That is why I use copper wires. Okay. Copper is the best choice out of all this. You can use aluminum also, but then aluminum has a problem of the impurities. So, therefore, conductivity will be compromised. That is why high purity copper wires are used. Actually, you must be knowing that in the electrical applications, electrical wires, they are mostly made of copper. You cannot replace it because of its high electrical and thermal conductivity. It can conduct electricity very nicely, and if at all there is a resistive heating, it can also take away, the heat can be easily taken away. So, that is why they are choices. So, after giving all this example, which you can always read more about from my classmate's book, how design of materials can be done or design of objects can be done, and based on the design how the selection of material can be done. So, what is the problem statement? Finding a new material with target properties is of tremendous importance for technological development in the fields like energy, national security, resilient structures, human welfare, everything, or rather we talk everything in this world. That finding new materials with the target properties is the main concern. If you want to send a rover on a Martian soil, or if you want to send an kind of a rover on moon surface, what kind of target properties are required, and based on the target properties can we design new materials. So, classical approach of material discovery is basically primarily based on trial and error, and it depends on what? Large number of costly and time taking experiments. The moment you are going to try and find out, you are going to make a lot of mistakes and learn from the mistakes and design it. That is going to be very costly and time consuming. And in this today's world, you do not have that much of time available to you. Normally, let me tell you, the material cycle from discovery to application is about 25 years, and that is very long according to many countries. So, hence most of the technological experts, they want to reduce this cycle time almost half. That means from 25 years to 12.5 years, or at max 15 years. So, how do you reduce it? That means you have to reduce the number of trials and experiments. That is why the AI and ML comes into picture. Can you design a material using this concept so that number of trials are reduced, cost is saved? That is the question we are going to ask. But what is the best trial and error approach? You can think about it. It is basically what is known as the Edisonian approach. You must have heard of Edison, Thomas Alva Edison, that is his full name. Okay. You can get it all this information from Wikipedia link I provided at the bottom. So, Thomas Alva Edison was one of the finest scientists world has ever produced. He has largest number of patents. He discovered electrical bulb, first time, something around 1895 or 96, I can remember that, and that was a game changer. And these are the different pictures of the trials he made. As you can see, it is written here, Edison and his team tested more than 3000 designs of bulbs between 1878 and 1880. That means within 2 years, they worked so hard, they tested 3000 different types of designs. That is what is called best example I found of trial and error. I do not think we can do it easily. 3000 different types of design, make the bulb, test it, oh my God, that is a massive job. So, Edison has a large team of people working with him, and you could have, if you read this Wikipedia, you learn about more about him. So, this kind of approach was good in those time, 1800, 1900, because there was no computers in those days. That is why it was very famous. And this approach is characterized by trial and error discovery rather than a systematic theoretical approach. That is what is known today's world, that is exactly what is known in today's world. But Edisonian approach is never always dealt with the problem of failure. There will be lot of failures and you are going to learn from failures. That is why it is not recommended nowadays. But then how to discover materials? One of the ways is intuition based discovery. Intuition means it is nothing based on any strong scientific foundations. It can be synthesis of material or synthesis preparation, it can be some test you do like mechanical test or test of any functional properties, electrical conductivity, thermal conductivity, or you can test it under certain conditions and find out. Based on that, either you can choose the correct one or you can discard the wrong one. Okay? That is the intuition based. That is not trial and error. Trial and error has no intuition. You simply have certain kind of a design in your mind, make it and test it. It does not work, again change the design. This does not work, again you change something else. Here that is not the case, it is basically intuition based. It is more like a you think over a lot and then got some idea which is probable to work, and many cases this actually works, because our intuitions are always happens to be quite useful. But there is something called serendipity. I do not know whether you know it or not. Serendipity is very important role in our material science and engineering. Why do material science? Every aspects. Okay. So, before I come back to this, I just want to give you this one. This is very important. I have taken from one of the best scientists in the history of humankind, Sir Alexander Fleming. You know that he discovered penicillin, the first antibiotic in the world, in 1928, and he wrote this on his, after he discovered, he gave this lecture when he received his Nobel Prize. When I woke up, I just saw, when I woke up just after dawn on September 28, 1928, look at it, September 28, 1928, the date is very interesting. I certainly did not plan to revolutionize all medicines by discovering the world's first antibiotic called or bacteria clear, but I suppose that was exactly what I did. This is a picture of the petri dish on which you are doing experiment. You can see this is actually Staphylococcus bacteria, the small dots, and this is a fungus which is growing. And near the fungus, there is no very less number of bacteria, most of them are dead, because the fungus was producing penicillin. So, he separated the penicillin, that is why he discovered the first antibiotic. So, that was a serendipity. And you know how it happened? Well, he was doing experiments for a long time, and one fine day or even evening, he was very frustrated. He basically left this petri dish along with all this thing outside his room. It was a cold day, September is basically cold month in UK, and he thought everything is over, nothing will happen, but next day morning was something different. So, it is very clear serendipitous discoveries happen when the person concerned worked hard to achieve something. That is what is said. In material science, serendipitous discovery happens in various places. This paper is very important paper, published in Indian journal Bulletin of Material Science by one of our classic scientists, Professor Robert W. Kahn. See, name of the paper is Challenge, Response and Serendipity in Design of Material. What all has been serendipitous? The most important serendipitous material, you know what, is aluminum copper alloy, what is known as a duralumin. And it was discovered in Germany by Alfred Wilm. Okay, his name is Alfred Wilm. What he was trying to do, let me explain. Alfred Wilm, head of a newly established metallurgical section in a German government research laboratory in Berlin in 1906, almost 120 years ago. He did not publish anything for almost a year. That is what Professor Kahn is saying, and this is from his paper. Now, what happened? He was working on a commercial alloy, or basically alloy contained 4 weight% copper, 0.5 weight% magnesium and 0.5 weight% manganese along with aluminum in the cast and roll conditions. And he examined its indentation hardness on a Saturday and went off for a leisurely weekend. Yes, he wrote, metallurgists are basically have leisure in these far off days. And on returning next Monday, he repeated the measurements, and just to be sure, the alloy was now 40% harder before what it was. He knew better to shrug off this finding as a result of mere careless measurements. He repeated the experiment again. That is what happens for the best of the best people, and determined the first age hardening alloys. What happened? Discovery was serendipitous, but not sufficiently so, because there was no basis available in finding any age hardenable alloys in those days. But you know, it was discovered in 1914 and it was used in 1918 to make aircrafts in the First World War. That is what is the. So, therefore, it was used by US Air Services in 1918 and did not knew these aspects. So, therefore, this is an serendipitous discovery. Martensite is a serendipitous discovery. I can't keep on listing them. Quasi-crystal is a serendipitous discovery. Martensite was discovered by Rudolf Martens, that is why. Quasi-crystal discovered by Danny Shetman, and similarly metallic glass by Paul Duage. So, all there are many actually, I do not want to list all of them, it will be a very large list. In material science, serendipitous discovery is very high. Let us talk about this one which we left behind. You know, this is basically glass ceramic. There is a ceramic material in which you have glassy phase along with some nanocrystals, discovered by Dr. Skutke in 1953. And how it was discovered? Furnace was not working properly, that is how it was discovered. So, it has been told to me, and I was looking at literature from various literature, I was trying to find out what is it. You know, this person, Dr. Donald Skutke, is actually did PhD from MIT, and then he was working as a glass research chemist and some company. And then what happened? He was doing experiments, and one fine day the furnace malfunctions or malfunction, and then he discovered that there are some crystal in the glass ceramics or in the glassy phase of ceramic. That is how the glass ceramic was discovered. If you are lucky, you can discover this also. There are many things you can discover, but obviously serendipitous discovery cannot happen every day. It happens sometimes. There are few reports. So, as you can understand, this is another way of discovering material. The first one was obviously trial and error, then intuition based, then serendipitous discovery. What else possible in this world? Can you think about it? Well, let us talk a little bit more on these aspects in the next lecture. I will start from these aspects. Thank you.